Okay, so we are continuing from yesterday, yes? Projectile motion. This is a little bit different to yesterday's. A couple of examples. I'm at the foot of a cliff, and it's given us what main thing to start with? Displacement. Yesterday it gave us the, do you remember? Gave us the, no, it gave us the acceleration. Yeah, and then we integrated to find the displacement. Okay, this time it's given us displacement. It's given us a gravitational constant for acceleration. It's also given us, it wants us to first find the velocity. So we're going from displacement to velocity. We differentiate. Differentiated. Nice and easy. And then you put the I. All right, now we look at the J. 45t becomes... Oh, I should have written this actually. That is completely wrong. dr dt, squiggle under the r, equals v bracket t. Everyone happy with that? Do we need a plus c? No, because we're differentiating, yeah. Okay, so that's number one done. Pretty simple. Number two, calculate the launch speed. Oh, interesting. When t equals 0, so we sub that in, 6i plus, what does that become? 45 takes 0, it becomes 45j. So we've got it in I and j. Think about it visually, what's happening. Bottom of the cliff. Remember yesterday, if we've got the velocity in terms of I and j, we can figure out the hypotenuse of the triangle, yeah? Which is the launch speed. Remember, speed is the magnitude of the velocity. So we simply do Pythagoras. Trig. So tell me what to do. We've got the I, which is 6, and the j, which is... So we need to put in... Very good. What do you get? Approximately 82.41, hopefully rounded correctly. When velocity equals 0. Because it's gone up and it gets to a point where we are no longer velocitying it up, if that's a word. We are now velocitying down. So there's this like sweet spot where you get to the top and then you go back down. Okay, so we can use this. Let's go back to our velocity equation. So what are we going to make it equal to 0? Yep, so we make the j equal to 0. Simple enough. Rearrange. So I found a time in this question. I made it very simple. Don't have to use your calculator. 4.5 seconds is when we hit the top height. Is that it? Have I finished? In the question, I cheated. I just made gravity 10. Displacement. Which displacement do we put it into? Height is the J. So you put 44.5 into the J. What was the equation? 45t minus half g. So wherever you see a t, you sub in the 4.5. There you go. So question 3 is actually a two-part question. It wants you to find the greatest height, but it also wants you to find the time of the flight of the projectile. Yep, so you can times the greatest height time by 2, or the end time, what's going to be equal to 0 when it lands on the ground? Vertical displacement is 0. So what could we make equal to 0? The J again. 45t minus half g t squared. So bring the 45 over. Actually, bring this over. Divide both sides by what? T. Sub in g equals 10. So is the timesing the halfway right? 4.5 times 2. I'm trying to show you all these different conditions that hopefully you've seen in physics as well. Okay, last question. Calculate the impact velocity of the projectile. So use that equation we found at the very beginning. And sub in 9. So it's the velocity it's going into the ground. So it's I'm trying to emphasize what? I've said it like a million times now. The different conditions.